What if you could travel faster than light? Imagine stepping on a ship, hitting a speed dial, and suddenly you're not limited by hours or light years anymore. Sounds insane, right? Stick with me. By the end, you'll know what would happen the instant you break that cosmic speed limit, how life and time might twist around you, and one weird, almost poetic surprise I am going to tease now and explain near the end. You might see your own arrival before you ever left. Weird, huh? Hold that image. So, quick setup. Light moves at about 300,000 kilometers every second. That's the universe's speed limit, at least as far as Einstein's relativity tells us. Why does that matter? Because everything about cause and effect, your coffee cooling, someone waving hello, is tied into light's rulebook. If you could ignore that rule, even a little, the whole bookkeeping system of time and cause gets messy. Tell me this while you're listening. If you could hop to a star tonight, would you go? Type the name of the first star you'd visit in the comments. I'm curious. Right away, immediate effects. Picture this, you accelerate past light speed. The first thing you'd feel. Not excitement so much as the universe turning into a hostile fleshlight. Light ahead of you compresses. Every photon you outrun piles up, shifting to higher and higher energy. Visible light becomes ultraviolet, then X-rays, then gamma rays. Think of standing in front of a welding torch, then a nuclear reactor. That's a pattern interrupt right there. Your view of the stars doesn't de-blur, it screams. You'd be hit by intense radiation coming from the direction of travel. That's one reason why faster than light travel is dangerous in a very literal way. But there's another immediate weirdness. Your headlights, or any light you point forward, wouldn't behave how you expect. If you could somehow outrun your own beam, the light you turn on would fall behind you. You'd be moving ahead of the message the light is trying to send. Imagine trying to see where you're going while the light lags. That's a wild mental picture, right? Mini suspense hook. And that's not even the half of it. Now expand the ripple effects. If one ship does FTL, the whole web of communication changes. Signals that used to take years could arrive before they were sent, if you play the geometry of relativity just right. That's not my poetic way of saying time travel. That's literally how some thought experiments go. Scientists at places like NASA and various universities have run the math and warned. Allow faster than light messaging and you invite causality loops. Models disagree on the exact numbers and setups, but the consensus is clear. Causality gets shaky. Fun aside, physicists have a thought experiment called the Tachyonic antilophone. It's a sci-fi sounding name, but it neatly shows how sending information faster than light can let someone receive your message before you send it. Weird, right? Imagine daily life under that rule. Mail-in news stop being linear. You could, in principle, receive a warning about an event before anyone had a chance to start it. Markets, politics, everything that depends on what happened when would be broken. That's a slow burn social earthquake. And it's not just communications. Navigation systems would have to be rethought. GPS relies on the time it takes for signals to travel. If some signals travel faster than others, you get conflicting maps of where things are. Boats, planes, even rockets would navigate in a world where now depends on who's watching. Here's a playful guess for you. And don't overthink it. If you could FTL commute to work, would you get there and arrive before your alarm went off? Type yes if you cheat time, no if you're ethical. I'll read the fun ones. Act 3 takes us to the extreme edge case. Push the idea until the math makes you squint. Suppose we somehow build a ship that doesn't just slip past light speed, but maintains it. Physics suggests massive problems. First, energy. As you approach light speed, your mass, and I mean your effective inertia according to relativity, appears to grow. Push closer and closer to light speed, and the energy required skyrockets toward infinity. It's like trying to push a boulder that turns into Mount Everest the harder you shove. That's why the usual story goes, you can't cross that barrier. Myth bust time. A common myth is just build a faster engine and you're good. Not true. It's not a mechanical problem alone. It's baked into how space and time relate. But let's play fantasy for a moment. Imagine somehow you do find a loophole. Tachyons have been proposed in theory as hypothetical particles that always move faster than light. We don't have evidence they exist, and most physicists treat them as mathematical curiosities. Another idea people throw around in sci-fi is warping space, contracting space in front of you, and expanding it behind, so you get to distant places faster without locally exceeding light speed. That's a clever dodge. Your ship sits inside a bubble, and the space around it does the heavy lifting. The math inspired by this, inspired by a real solution to Einstein's equations, shows it might be possible in theory. But here's the catch, you need exotic energy conditions. Translated, you do need forms of matter or energy that we've never found and that may not exist. So, while Alcubierre-style warp drives are cool on paper, they're not a menu item at your local rocket shop. Pattern interrupt. Quick fact, if you could warp space and get to a nearby star in minutes, you'd still face the radiation problem when you arrive. Space isn't a friendly park. Now let's turn to myths and clarifications. Myth: FTL travel equals instant time travel. That's an oversimplification. Yes, certain FTL frameworks imply causality violations, which is the physics way of saying you could get messages before they're resent. But not every warp drive idea automatically breaks causality if you're clever about how it's constructed. We don't know for sure. Models disagree. Some physicists think global constraints of the universe prevent paradoxes. Others think any FTL trickery would create loops. That uncertainty is real and beautiful in a way. It keeps the question open. Okay, remember that weird tease from the top. The one about seeing your rival before you leave. Time for the reveal. If you set up FTL signaling cleverly, relativity lets you construct frames of reference where events reorder. Imagine you beam a signal to a spaceship moving in a particular direction. In one frame, the signal goes forward in time. In another, because of the relative motion and the FTL speed, that same signal appears to arrive before it was sent. It's like sending a letter and finding it waiting in the recipient's mailbox yesterday. This is the core of the tachyonic and tylophone thought experiment. So, the special fact, faster-than-light communication can allow reception of a message before its transmission, meaning, in a very real sense, you could see something happen before it happens. Reflect on that. What does it mean for responsibility, for warning someone of danger, for free will? Drop a line in the comments. Would you want to get warned about your own future? Mini takeaways. Remember these. First, outrunning light isn't a neat shortcut to instant travel. It drags along radiation and energy problems that are brutal. Second, FTL upends causality. It can let messages and events swap order. Third, some theoretical work warp bubbles. Tachyons gives creative ideas, but they demand exotic physics we haven't found. Models disagree on the hard limits, but the broad picture is consistent. FTL is full of paradoxes and payoffs. Before I wrap, a quick ask: if you liked walking this weird line between physics and thought experiment, subscribe. We do more of these dives, real ideas, strange consequences, and a lot of what-if thinking that actually connects to how the universe works. Hit the bell if you want the next mind bender, and join the curious crowd. Almost done. One last cliffhanger to pull you forward. If faster-than-light travel flips time and breaks cause and effect, what would happen if two ships, both go in FTL, exchanged messages and each saw the other respond before they sent their own? That's a recipe for paradox, and it's the seed for our next episode. What if information could travel back in time? Want that? Smash the like button and type backtrack if you want us to chase the paradox in the next video. Final thought to leave you with while you wander off into coffee or chores. Speed is more than motion. It's the ledger of events, the accounting of cause and effect. Break the ledger and the story changes. Would you rewrite history if you could? Or would the danger of rewriting too much scare you off? Tell me below. I'm reading. All right, that was our trip through FTL territory. Thanks for staying curious. I'll see you in the next one, where we might just try to call yesterday.